All right, what we're asked to do in this problem is find the derivative by the limit process and then find the equation of the line tangent. So we're given the function f of x is equal to 1 over x plus 1, and we're given the point 0, 1, and we're supposed to find the line tangent to this function. So this is what I'm going to do. I'm going to start with this idea that I already have. I know that f prime at x, because your professor is asking you to use the limit process, f prime at x is the same as the limit as the change of x goes to 0 of f of x plus change of x minus f of x all over the change in x. This is, call this just FITBA. Fill in the blanks. Fill in the blanks. So that's what we're going to do here. And I think it's going to come out looking like this. You don't have to repeat this portion for your professor, but you have to continue to declare that this is your intention to take this limit. So I'm going to say that the limit of the change of x approaches 0 of 1 over x plus change in x plus 1 minus 1 over x plus 1 all over change in x. This is what this says here. It says in the first part, every place in your function that you found x, put x plus change of x. So I found x here. So I wrote, this was where my x was, right here. And I put x plus change of x in there, and I left the rest the way it was, and there it is. And the second part says just put in f of x. So f of x is 1 over x plus 1. And it says lastly that we're going to put this whole thing over that change in x value. Good? So this gets a little bit weird looking, but you don't have to kind of freak out about it. So what I'm going to do is this. I'm going to multiply this side by x plus 1 over x plus 1. I'm going to multiply this side by x plus change of x plus 1 over x plus change of x plus 1 to get a common denominator, and then I'm going to start to simplify. So it's going to look like this. So I'm going to get the limit, I have to keep declaring this for your professor, is equal to x plus 1 minus x plus change of x minus, plus 1, right? All over x plus 1 times x plus change of x plus 1. And I hope you're buying all of that. I like that. You know what I'm going to do, if you don't mind? This is a complex fraction, so this is like this. I'm going to bring this up and multiply by the reciprocal, which puts this change of x here. Kind of save myself a step. I can see what you might want to do, and I'm begging you. I am begging you. Don't rush into a bunch of unnecessary algebra. So you might be tempted, like, I'm just going to go ahead and expand this out. You're going to spend the rest of your life expanding that out. But this can be cleaned up really easily by just distributing this negative sign, can't it? So I'm going to go ahead and I'm going to do that. So I'm going to declare the limit again. Make your professor happy. So x plus 1, when I distribute this negative sign, I get negative x. So negative x, negative change in x, and negative 1. Hopefully you can see that we're going to get something out of this. And I'm going to get this change of x and just rewriting the denominator. X plus 1 times x plus change in x plus 1. So hopefully you're seeing this come together. Now I'm going to simplify again. So I'm going to go ahead and simplify this. X and negative x is 0. Positive 1 and negative 1 is 0. That leaves me with just this. It leaves me with the limit as the change in x goes to 0 of negative change of x. This one is that one. This negative sign is that one. Over change of x times x plus 1 times x plus change of x plus 1. Holy macaroni. Seems like a lot, doesn't it? But everything is actually going fine. Everything is going fine because I'm going to simplify again. And as I simplify this, change of x over change of x is 1, isn't it? So I'm going to declare my stupid limit again to keep my professor happy. Change of x over change of x is 1, so this goes to 1, this goes to 1. So I get negative 1 over x plus 1 times x plus change of x plus 1. And you might be going, dear Lord, Charlie, are we ever going to finish? Man, we're done. We're done because now I'm going to go ahead and take this limit. And to take the limit is just to say that now I realize that if I let this change of x equal 0, the function will still be defined. So I'm going to take that limit, and I'm going to say that f prime at x is equal to negative 1 over x plus 1 times x plus 0, that's change of x, plus 1. And we can see that x plus 1, x plus 0 plus 1 is just x plus 1, isn't it? And x plus 1 times x plus 1 is x plus 1 squared. Isn't that right? X plus 1 squared. So now we look at this and we're like, okay, I need to go ahead and take this limit. Right? If you remember, we had the point. What was the point that we had? It was 0, 1. We had the point 0, 1. So I need f prime at 0. F prime at 0 is 1 over 0 plus 1 squared, which is equal to negative 1. Now, my God, we're finally finished. We're going to use this y minus, remember this y minus y sub 1 is equal to m times x minus x sub 1. Well, we found this limit. We found this derivative. We found this slope, and the slope is negative 1. So m is negative 1. That's the slope. That's what first derivatives are, slope, right? We have our x sub 1 value. Our x sub 1 value is 0, isn't it? Our y sub 1 value, right, the value that they gave us was the 0.01, is this, right? I'm going to go ahead and distribute this. I get y minus 1 is equal to negative x, isn't it? Therefore, the n equation of the line tangent is y is equal to negative x. Look, to get rid of this negative 1 here, I'll add 1 to both sides, so plus 1. There's our tangent line. It's a pain in the neck, you guys. What's really a pain about it is the limit process thing. But we're going to move away from it really quickly. But you have to prove that you can do it. So I know that you guys are going to crush this. So continue your hard work. Proud of you. If you have any questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks, you guys. Peace.